Hi, this is the fourth of the CPD training sessions for College Cambria. Just going through a little bit of how to change a logic circuit, something like this, into a easy program. Obviously, if we were to build this, we've got 4 input keys, 4 output LEDs, which is just C0 to C3, A, B, C, D on this side. And then what we've got here is we've got 4 logic chips. So we've got one 7408 here, we've got a second one here, and a third one down here. We've also got a NOT gate chip, something like a 7404. So I've set this up in such a way that there are definite combinations to turn each light on. The first light is turned on by A, B, C, D, and this one will come on. The second light is a combination of A and D. The third light is B, C and D together. And the fourth light is just A and B together. So each one of those only has one possible input combination that will turn it on. Okay, so that's what some of the NOT gates are for, to give it a definite. Now obviously with a little bit of playing we could cut this circuit down using a Carnot map or some other trick with Boolean algebra that you may prefer, but whichever way you do it, this is set for just definite inputs. We don't want any indefinite inputs. Okay, so what I've looked at here in order to do the program is I've looked at assigning each one of these a bit, which will be port B in the program, and each one of these has therefore a value in binary. So key A is a value of 1, key B is a value of 2, key C is a value of 4, and key D is a value of 8. What that means is that when there is a value of A, B, C, D, that is a total of value in decimal of 15, and that turns light A on. For light B, it would be a total value of 9. For light 3, it would be 14. And for light 4, or C3, it would be a value of 3. So I'm just going to show you through the program that I've written, and then we'll go through how to make it. So what we've basically done here is really simply, I've set up this 4 switches to be port B0, B1, B2, and B3. I've set up the lights to be port C0, C1, C2, and C3 as an output to the LEDs. So I've taken an input and I've read port B, and I've set a variable up for port B, which I've called input. And if I look at the input variable, we'll do it up here actually. It's easier to do it on the Project Explorer. If we look at that, what we can find is I've set it up to read it as an integer, so as a whole number. So I could have read a byte and it would have given me exactly the same result, to be fair, but in this particular case I've set it up to be an integer. So then it just simply goes into some decisions. So if the input equals 15, I turn on the first LED. If not, I make sure it's off. If the input is 9, I turn on the second LED. If not, I make sure it's off. If the input is 14, I turn on the third LED. If not, I make sure it's off. And if the input equals 3, I turn on the fourth LED, and if not, I make sure it's off. We've got a very short delay here, and then it just wraps round back to the beginning. So if I just hit play, we can replicate exactly what I did on the other software, which is A, B, C, D, turns on light number 1. A and D together turn on light number 2. B, C and D together turn on light number 3. And A and B turn on light number 4. So obviously doing it with a microprocessor has several advantages. It's obviously going to be much quicker to write this program and just connect LEDs to the correct output ports and switches to the correct input ports. Obviously we'd need resistors and possibly transistors for buffering on that as well. Okay, so I'm just going to run through making this program. So new embedded project, not going to save changes. Okay, and I'm going to set it up as an Uno R3 PDIP because again that's what I have. You may have the surface mount version. So when it's all up, the first thing I'm going to do this time, I'm not going to bother with a display, we don't need one, so I'm going to put in my inputs, which are a toggle switch, and I'm just going to place in 4 of those. Oops. And then I'm going to select 4 outputs, which is just going to be any of the LEDs will do. They all do the same job. I just happen to like the green ones. So 1, 2, 3, and I've done it again, 4. Okay, so there we go. Now the next thing to do is make sure your properties panel is open, and this is going to be port B0, which is down here, port B1, which is here, port B2, and port B3. Okay, so the next bit is changing these to port C. So I'm going to go port C0, port C1, port C2, and port C3. And that should set up everything we need. So I'm actually going to close the properties panel and get it out of my way. I always bring it back if I need it later. So there's nothing to begin with this. There's no initialization or anything like that. It's just switches and LEDs. So on this one we're going to go straight into the loop. And then the first thing I'm going to do is call an input. And I'm going to set this up to read port B, which is these ones. Now I'm also going to set up a variable called input. Call it anything really, and I'm going to make it an integer. Okay, so I'm going to pop that in there. Now this time as well I'm going to use the entire port, but I'm going to use masking, and I'm going to tick 1, 2, 3, 4. That means if anything is active on any of these 4 lines, then the system will just ignore it. It doesn't matter what their levels are. So just keying it to make it just the switch lines. The next thing I'm going to pop in is a decision, and as we know, to make 15 go, so the decision is if input equals 15, giving us 2 branches. Then the first one is component macro and a component macro, and I'm just going to pop that in there, and I'm going to pop that in there. So if it's equal to 15, I want to turn light 1 on. So I'm just going to open up the component macros list, and I'm going to look for LED number 1, and I'm just going to say turn on. Exactly the same on this side. LED number 1, turn off. Drop this down a little bit, and we just replicate this 3 more times, but with our different answers. So this time it's input equals 9. And 2 component macros dropped in. This time though it's LED 2 or C2. So on my list I want turn on, and on my list I want turn off. Right, so this time the number we're looking for is 14. And we're turning on LED 3. And on this side turning it off yet again. Finally we're looking at LED 4 now. So same format again. And we're going to turn LED on. And LED off. Very final part of the program, very simple one. This is a delay, and you can make that whatever time you like. I find it flashes a bit on 1 millisecond, so I'm just going to change it to 50 because that works nicely. And that should be the program done. So we can hit play. And we can check A, B, C, D, turns light 1 on. Light 2 should be A and D. Light 3 should be B, C and D. And light 4 should be A and B. Right, so I've made a small error again. I've forgotten to put the decision value in for this one. So that's rushing for you. Input equals 3. Okay, and now we can hit play again, and this time we can check, and away it goes. So it's very simple to find errors if you make them, or omissions if you make them, and that's one of the things I like about Flowcode. Debugging is very simple. You can see if you've not written something correctly or not at all, as in this case. So it's always a quick glance over can usually find the fault for you. So hopefully that's explained using one method for replacing your logic using decisions. There are others, but it's just a quick introduction to the idea. Obviously you can change these decisions to greater than 9, for example. So we could turn LED on 2 on if it was 9 or greater by just putting greater than 8, or we could turn LED 2 on by putting greater than 9 and it would come on with LED 3 and LED 2. So that would be quite a simple little change, and you might find that when you do a Kano map or something similar, and this would actually happen. So greater than 8, and we'll just run through that. So when I put A, B, C and D on together, the second light is now on as well. Okay, essentially you'll find that so long as that pairing is on or above, that light comes on. So when we do B, C and D for this one, both lights will come on, but when we do A and D, only that one will come on, and if we do A and B, only that one will come on. So it's simple to alter as well if you find that you wanted the states to come on in different categories. Alright, that pretty much concludes the CPD little run-throughs that I'm going to do for you. So anybody who wants any help in the future, give me a shout. I don't pretend to be the world's biggest expert, but there are quite a lot of explanations out there on the internet. I found a particularly good one. It's called Student Companion. It is unfortunately Flowcode 5, so the layout's a little bit different, but the guy goes through everything in great detail. I've also found the forum from Matrix is quite useful for little hints and tips, and I found Matrix themselves are quite useful at getting back to you via the forum if you have any problems.